After discussing the first factor affecting rate of reaction, that is concentration, let us today talk about temperature as another factor affecting reaction rate. An experiment. Procedure. Measure 30 cubic centimeters of 0.1 molar sodium thiosulfate into 5 different conical flasks and label them A, B, C, D, and E respectively. Mark a cross X on a white piece of paper and place flask A with its contents on the paper. Add 5 cubic centimeters of 2 molar hydrochloric acid, or you can use 2 molar sulfuric 6 acid. And at the same time start a stopwatch. Record the time taken for the cross to be invisible when viewed directly from above. Record the time, and finally repeat the experiment using solutions at 30 degrees Celsius, 40 degrees Celsius, 50 degrees Celsius, and 60 degrees Celsius. That is for B, C, D, and E respectively. Record your results as shown in the table below. So from this experiment, the one in flask A is done at room temperature, that is for 25 degrees Celsius. Then it is clear that the one in B will take 30 degrees Celsius, C 40 degrees Celsius, D 50 degrees Celsius, and finally the one in flask E goes for 60 degrees Celsius. Let us look at the experimental results. Temperature of sodium thiosulfate so that is room temperature, degrees Celsius, 40 degrees Celsius, 50 degrees Celsius, and finally we have 60 degrees Celsius. Then we have time taken for the cross to be invisible, to disappear. And finally, we have 1 over t. This is in seconds as well in seconds. So this is the experimental results. We want to record the result in this table. Where we have temperature. It's recorded at different intervals. So the first one goes for 28.57 seconds. That is 14.15, 12.75, 7.75, 5.60. It is clear that as the temperature increases, the rate of reaction is faster. And the sodium thiosulfate is able to react with the hydrochloric acid faster to form the precipitate. And this is a yellow precipitate, and this is what leads to the disappearance of the cross. This is what makes the cross to be invisible. Because before the reaction takes place, it is clearly visible. It is easy to see through and have X well seen. But the moment a precipitate that is yellow is formed, there is no way through to see the cross. It is clear that when the temperature is high, then the precipitate forms so fast. The reaction takes that short time, and that is what makes the cross invisible. Let us record the inverse of time. This one known as 1 over t. So this is 0.035. This gives 0.071. This is 0.078. The inverse here is 0.129. Finally, 0.178. Now, this is how the reaction between sodium thiosulfate and hydrochloric acid will show different time recordings, that is at different temperatures. We have seen that at room temperature, it takes a little bit longer time compared to when it is 30 degrees Celsius. So the temperature increase leads to speed of molecule. The speed of the molecules is increased, and therefore the frequency of collisions is higher. At this higher temperature, the molecules have now increased kinetic energy. Therefore, the number of molecules with the minimum energy required for an effective collision is higher. So you realize that there is high collision, hence high reactivity. The rate of reaction will be so high. The particles of the thiosulfate and that of hydrochloric acid, or if we use sulfuric acid, will really collide very fast, and that faster collision is what will realize the faster formation of the yellow precipitate. So this is the kind of reaction that we have. This is the summary of the entire procedure. There's a point that you continue to add. The yellow precipitate has still not been formed at that point. Then there's a stopwatch there. There is a thermometer to record the temperature up to the 30 we are talking about. We are talking about the 60 we are talking about, the 50 we are talking about. Now, from this experiment, this is the kind of reaction we are going to have. Sodium thiosulfate plus hydrochloric acid leads to formation of sodium chloride, water, sulfur, and sulfur 4 oxide gas. To balance the equation, we have T, sodium T2, then HCl also has a coefficient of 2. So this is the yellow precipitate. This is what will give yellow precipitate. And that is why the cross cannot now be visible. As temperature increases, the time taken for a reaction reduces. Thus, the rate of reaction increases. Hence, rate of reaction is directly proportional to increase in temperature. or we can simply say directly proportional to change in temperature. To generalize the whole, whether lowered or increased, to change in temperature. This implies that when the temperature is lowered, then the rate of reaction also lowers. And when the temperature is high, at increased temperature, there is a faster rate of reaction. And that is why at 60 degrees Celsius, that is at higher temperature, it takes 5.62 seconds for the reaction to complete, or for us to have a complete reaction. Then at 25 degrees Celsius, it takes 28.57 seconds. At lower temperature, there is more time required for that reaction, meaning the reaction is slow. The rate of reaction is that low. And at higher temperature, that is at 60, according to our experiment, it takes a shorter time for the reaction to reach a completion, meaning the rate of reaction is higher. There is more collation between the reacting particles, and it takes now a short time for us to realize formation of the yellow precipitate. Now, when we now look at the relationship between 1 over T and type of reaction or rate of reaction, then it is clear that rate of reaction is as well proportional to 1 over T. Some of the possible sources of error during such kind of experiment may be measuring temperature of the solution may not be accurate. Measuring exact time taken for the cross to disappear as well may not be that accurate. But indeed, this is the picture of how such kind of reaction would take place, and this is how we're going to have the formation of our yellow precipitate, which will eventually lead to the invisibility of the cross made on the white piece of paper. In the reaction between sodium thiosulfate and dilute hydrochloric acid, colloidal sulfur is formed and gets deposited in the conical flask, making the white piece of paper, the cross in the white piece of paper to be invisible. Is deposited in the conical flask, making the cross on the white piece of paper to be invisible. The time taken for the cross to be invisible, we have said, varies with the varying temperatures, and the higher the temperature, the shorter the time for the cross to be invisible. And the reverse is true. This therefore shows that increase in temperature increases the rate of reaction. And when time is now plotted against temperature, then this is the curve that we realize. X-axis, Y-axis. This is time against temperature. This is the kind of curve that we'll have there, meaning at lower temperature it takes more time, at higher temperature it takes less time. Less time, more time. And when it is less time, it means faster rate of reaction, higher rate of reaction. When it is more time, it means there is slower rate of reaction. So that is when temperature and time are plotted. That is time against temperature, and that is the curve that you're going to realize. The temperature and 1 over time when plotted will again realize a straight line graph. This factor can also be illustrated practically by using magnesium ribbon and dilute hydrochloric acid. And the same thing that happened in the case of concentration will also take place when we talk about the magnesium ribbon and HCl. The real difference between this magnesium and HCl and that for hydrochloric and sodium thiosulfate is that in this other one, the way of knowing the rate of reaction is based on the volume of the hydrogen gas that is produced. In the other case, what shows the nature of the reaction taking place is all about the formation of the yellow precipitate that leads to the disappearance or invisibility of the cross on the white piece of paper. Now, we have concluded from this experiment that at higher temperature there is a high rate of reaction, and at lower temperature there is a low rate of reaction. And that is all about temperature and reaction rate.